Hello everyone, we've looked at coordinates, we've looked at translations, so today we're going to look at reflections. So first I want to think, what is a reflection? Where have you seen reflections before? And what do you notice about them? Now probably many of you thought a mirror, maybe some of you thought reflected in a puddle or a body of water like that. And you might not know too much about them, they show what's back at you. If you look at them at an angle, you can see other things. But actually, when you look at reflections, things are not reflected the right way. That's why you might have seen this an ambulance, which has written on the front here, ambulance written backwards. And the reason it does that is that when things are reflected, you actually see them backwards, like this. So you can see a picture of an ambulance in a mirror, and here the writing appears to be the correct way around. That's actually why it's on ambulances like that, because often when ambulances are overtaking cars, people see them in the mirror. Now, in geometry, what happens if we reflect the shapes? Well, you can do this as a mirror, and if we were in class, we would do this as a mirror. You can just use geometry, and that's what we're going to talk about today. I've given you a digital tool on the blog, which you can use to practice, but it's really good if you can wrap your head around how you use this rule. So first, you want to measure how far away the shape is from the mirror line. And then you want to mark out where the reflection would be. Whoops, I've got two any E's there. The same distance away from the mirror. The mirror line, by the way, is this dotted line here. This is where we'd put a mirror if we got it. So in the case of this orangey pink square, it's right next to it. It'd be just the other side of the mirror. And then once you've marked out, colour in the appropriate square. If you did it for this, you get one here, one that's 1, 2 away. So 1, 2, you'd have this one here, and here you go 1 away. So you'd have this one here. It would look like this. Now, when the pattern is reflected, every point remains the same distance, so you can reflect whole shapes, not just individual squares like before. The shape doesn't change size when it's reflected, but it can change direction, which we'll look at in some of your independent tasks today. So first, have a look at this, pause the video and think, what's the same? What's different about it? Well, in both images, it's showing how to measure the distance from the vertex, the corner, to the mirror line, so the reflection can be completed. And the mirror line is in different positions. In one of them, it's horizontal, okay, going along the x-axis. In one of them, it's vertical, going along the y-axis. If you wanted to do it, you could do this, for example. So you'd measure this out, measure this down here, put the point in, draw the line, measure this as one away, do this one, finish this. Why don't you try and draw this one out and try and do the reflection? So the whole shape is one square away from here, and it's 3 squares high. 5 squares wide at the bottom. Is it 5 squares? 1, 2, 3. Sorry, 4 squares wide at the bottom and 2 squares wide at the top. And then when you've done that, here's your independent task. There are 4 different things to try here. This one in particular is very tricky, so I'd be very, very careful with this one. If you've got a small mirror at home, like maybe a makeup mirror or something like that, or just a thin one you can put down, it's really good if you can put this on your mirror line afterwards to see if you get the same shape in the same place. That's how you know you're accurate. This is a really difficult one to do remotely, so really stick at it, and I'll be very impressed if anyone can do all of it and show me some really neat looking diagrams drawn out on squared paper. Good luck, and as always, let me know how you get on.